Hello friends, I am Sunil and today I will discuss about the corrosion. Basically, most of the time students afraid from this topic from corrosion. This is little bit kind of they think that this is kind of confusing or very boring kind of topic. So today I will discuss about the corrosion and I will discuss basic of corrosion, how corrosion occur, what type of test we perform to measure this corrosion, and what type of the corrosion can be there, and what is the reason behind the corrosion. So I will quickly discuss about the corrosion. So first of all, what is corrosion? Corrosion is the degradation of a material due to reaction with its environment. It is the degradation in the material due to reaction with its environment. We have listened about the rusting. Sometimes we confused about what is the difference between the rusting and corrosion. So basically these both are same. The term is different. Generally rusting term is used for the corrosion in the steel or iron or ferrous material. But in case of corrosion, we generally, in case of aluminium or non-ferrous material, generally corrosion term is used. This is very detrimental for the material, especially like metallic material. It is very detrimental. And so, what is the reason or cause of the corrosion? I will discuss about first of all cause. Actually, corrosion always occur where there is a potential difference between the two material or within the material. So a potential difference is the main reason to corrosion to occur. So what is this potential difference? In electrochemistry, we suppose the potential of the hydrogen electrode as zero potential. So we measure the potential of any material or any metal with respect to hydrogen electrode. Suppose for hydrogen we take it zero, this potential difference, potential of the hydrogen electrode is zero. So we measure the potential difference of any metal with respect to this hydrogen electrode, and the series which shows this potential difference between the various metals or alloys, this is called the EMF series or galvanic series. EMF or galvanic series So this basically shows the potential difference. Now and this series, suppose in center we have hydrogen. It has zero potential. So the metal lies above this having positive potential, like iron, copper. These have positive potential. Suppose iron have 0.77 approximately, and the metals below this like zinc, aluminium, magnesium, these have negative potential. So these which are below this hydrogen electrode are called active metals, the metals which are above this hydrogen electrode are called noble metals. So when there is corrosion, then most of the time the active metals will corrode first before this noble metal. So there will be a kind of reaction, and these are the anodes. The metal which is more active is called anode, and the material which is less active or noble is called cathode. So these are kind of cathode and these are anode. So this is about the potential difference. This is the main reason of corrosion to occur. Now I will discuss the reactions which takes place during the corrosion. There is one anodic reaction and one is cathodic reaction. Cathodic reaction. The reaction which release the electron by dissociating into its ion is called anodic reaction. Like suppose this is zinc, it will dissociate into zinc plus ion and gives the electron. It will give the electron, then this is called the anodic reaction. Okay, this will give the electron and it is called, this is metal ion, this is electron. So this is anodic reaction. This is also called oxidation. So oxidation or anodic reaction are same and this take place on the anode. We can remember this by both oxidation O and anode A has vowel in the starting of these words. So and similarly in cathodic reaction, this will accept the electron or consume the electron. Like hydrogen ion will receive the electron and it will produce the hydrogen gas H2. So this is a cathodic reaction. And also this is called reduction. This cathodic reaction will take place at the cathode. So there are two reaction, anodic and cathodic reaction, or these are also called half shell reaction. Okay. So in the if two metal are going to be corrode, like one is zinc, one is copper. These two metal are in connection. So which metal will corrode first? Zinc, because this is in the lower side in the EMF series. This have active potential. This shows active potential. This shows noble potential. That is positive potential as compared to hydrogen, and zinc has negative potential as compared to hydrogen. So zinc will corrode as compared to this copper. And we think that corrosion is detrimental always, but sometimes it is beneficial also, because have you listened about anodization? Anodization is done on the aluminum alloys. This is used for aluminum alloys anodization. And chemical machining is also based on this corrosion process. So sometimes it is beneficial. And anodized aluminum alloys are used for decorative purpose. Next, there is many types of corrosion. Now I will discuss about the types of corrosion. There is many types of corrosion. One is very common is uniform or general corrosion. Another one is pitting corrosion, crevice, or stress corrosion cracking, SCC, stress corrosion cracking, and many more. There are many types of corrosion. Basically, I will discuss here about the uniform or general corrosion and pitting corrosion. Uniform or general corrosion is this we normally face everywhere in the environment, because when we see some rusted material in the an environment like an iron pillar or something, this is very common, and this occurs on the whole surface of that that equipment or object. So like this is zinc, so it is exposed to the environment. This will uniform corrosion will occur at whole surface on all the sides which is exposed to the environment. Okay, and okay, whereas the pitting corrosion is a kind of localized corrosion. This is localized corrosion. In case of pitting, suppose this is a aluminum alloy, and this is aluminum alloy, and this is second phase particle Al2Cu. So Al2Cu has a noble potential as compared to this aluminum alloys. This is more active aluminum, whereas this is noble. So due to reaction, anodic and cathodic reaction, this particle will start to this material near this particle will start to corrode, and it will result in to escaping of this second phase particle. So this will give us a pit kind of here pit. This will result in a pit. So this is a pitting which occurred due to potential difference of two material or metals which are in connection with each other. So this is very detrimental, because the material fail we don't know when the material will fail, because general corrosion we can see by our eyes, naked eyes on the material, but it cannot be visible by naked eye on the material. So this is more detrimental, pitting. And so there is one more thing very important, area factor. When we are designing some structure, we have to always keep large anode and small cathode. As we know, many of you are thinking that anode is always the corrosion occurs at anode, but why we are taking here large anode and small cathode, and how it can be beneficial. Large anode, small cathode is always beneficial, but small anode is detrimental as compared to this large anode, because as we suppose this is anode and this is cathode, this is large. As we know that anode always supply the electron, and the rate of supply of the electron and consumption of the electron will always be same. So if cathode is large, then it will require the more electron or consume the more electron. So anode have to supply these electrons. Suppose this is required 100 electron, so this much area has to supply the 100 electron in a fixed time. So the rate of supply, because area is very small, this anode area is very small, so the rate of supply of electron, that is the process of corrosion, will be very fast at this area. Whereas if this is a large part, then it will supply the electron slowly to this cathode. That's why the large anode and small cathode is beneficial as compared to or less detrimental as compared to small anode, large cathode area. So next is tests. Which what type of test we can perform to measure this corrosion? So one is weight loss method. This is generally used for general or uniform corrosion, in which we immerse the sample. First we measure the weight of the sample, then we immerse in a 3.5% NaCl solution or any kind of solution for a particular time, like for 1 month or more, and then we measure the weight after the 30 days or any times, and then we measure the difference in the weight. Hence we can find the corrosion rate. Second one is like potentiodynamic polarization test. Potentiodynamic polarization test, or this is also called TEFL test. TEFL test. This is this is an electrochemical test that is based on direct current, DC. One more is electrochemical impedance spectroscopy, EIS. This is based on alternative current, and the equipment that is generally used for corrosion testing is called the potentiostat. Okay. So I think this is enough for this topic, and I hope that you understood the basic of the corrosion, how it occurs, and this is the only game between the anode and cathode. One is anode and one is cathode, and the main reason is the potential difference between them. So like the materials which are in the series at the below side will always get corroded as compared to the upper material. And one more thing I want to tell you is the galvanization. Galvanization is term related to corrosion or protection of any material is generally used, because galvanization is in this galvanization, any material which we want to protect, like iron, we want to protect this from corrosion, then we will get a coating of zinc here, so that zinc has a more negative potential or more active, so it will always corrode zinc first, then iron, then it will protect the iron, and is at place of this iron, this zinc will corrode. So hence it is a kind of sacrificial coating, it will protect the iron. This is called sometimes this galvanized steel term is used. Steel is galvanized with zinc, or zinc coating is used on steel. So this is all for today, and hope you understood this basics of corrosion. Please like this video and subscribe my channel. Thank you.